So we're going to solve one more of these graphically before we move on to algebraically. So the key things we want to notice here, based on our absolute value function, we should know our vertex is going to be at -1, -4. We know we're going to have a horizontal line, and y is -2. And we know we want to get the values of our absolute value below the horizontal line, since we're looking for them to be less than that -2. So the key here, again, you can graph this on your calculator, but if you want to do it by hand, you can do that as well. You can plot our vertex here. Since we're not multiplying by any numbers, we're not going to have any kind of vertical dilation, so no stretching or compressing. So the slope going up and to the right should just be a +1. You can find those values there. And slope going to the left should be a -1. We can find those values there. So if we're just looking directly which values are below that line, so then our smallest x value there is going to be at -3. We can include it because we want the values less than or equal to. And then our biggest x value we can hit there would be at +1. So those would be our solutions there. Now, if we want to do this algebraically, as usual, we start by isolating the absolute value expression. So when the absolute value expression is by itself on one side of the inequality, apply one of these two rules to solve the inequality. So if it's bigger than a number, a is positive, then you can rewrite it as x is less than -a or x is greater than a. When it's less than a, you'll put it in between the -a and the +a. So these are just kind of rules you're going to have to learn and apply them. So if we want to solve these inequalities algebraically, so here we've got absolute value 4 minus x plus 15 is greater than 21. So we have to isolate. So we subtract that 15. Now our absolute value is greater than +6. So when we pull it outside, we'll say it's either less than the -6 or greater than the +6. So then we can solve, subtract the 4, -x less than -10, divide by -1, make sure you switch your inequality, x is greater than 10. Or on the right-hand side, we subtract the 4, -x is greater than 2, divide by -1, again, we have to flip the inequality, x is less than -2, so then we can graph our solutions there on the number line. Here in step B, again, first step we want to isolate the variable, so we'll need to add 10. So -2 plus 10 is 8. Now this time we are less than or equal to a value. So we're going to say it's less than that less than, greater than, greater than the negative value and less than the positive value. I never separate it like this. I always immediately put it in the middle here. I think it helps me. It's a little easier to see. So then we can subtract 4. X is going to be greater than or equal to -12. Subtract the 4 over here. X is going to be less than or equal to 4. So those are our values here. And we can make it just into one long phrase here. X is going to be greater than or equal to -12, but less than or equal to +4. We can graph that here. These are both including the values. So we're here at -12. We're here at +4. And everything in between here is going to be a solution. Make sure when you are plotting these on a number line, you are coloring in as best you can so that we can see what your solution actually is.